Hi, today we are going to learn how to sketch modulus function. Now before I begin, let me just recall what is modulus. Now, when I modulus something, if the result is positive, then it will take that result. Now, however, if the result is negative, you take the positive of it. Example, mod x minus 2. Now, if x is 5, 5 minus 2 is 3. 3 is positive, so you take the modulus of it, it is still 3. Now, whereas if x equals to 1, you put it inside the function, x1 minus 2 is minus 1. You take the modulus of it, so you take the positive value of minus 1, which is 1. Now, the first two examples I'm going to show you is how to sketch these two linear modulus function. All right, it's a modulus of a linear function. Now, let me generalize the function first. This function can be written as y is equals to a f of x modulus of it plus b. Now, when given a function like this, what are the steps to follow? First, I will sketch what is f of x. Then, I will sketch the modulus of it. Then, I multiply it by a. Then, I add b to it. Now, it is like the BODMAS rule you learn in primary school. First, you do whatever is inside the bracket. Right? But after that, we do the mod. Okay? After that, followed by times, and last is addition. So it's kind of similar to your BODMAS rule. Now, let us begin by doing the first example. Let us sketch the graph x minus 1. X minus 1, cut the graph, the y-axis at minus 1. Cut the x-axis at 1. So your graph will look like this. Okay. Next, we are going to mod it. Okay. Now, if I mod it, then this point minus 1 will become 1. So this graph is reflected upwards. Okay, anything negative of it will become positive because of this mod function. Now we have finished these two steps. Next, we do a, so that which is 3. So we multiply it by 3. Now when it takes on the value of 0, this one is 0, mod x minus 1 is 0. You times 3, it is still 0. 0 times 3 is still 0. Now this is 1, you times 3 becomes 3. So this part of the graph is this way. Okay. Now how about this side? All right, it is always symmetrical. Okay, so this point will be here. Modulus of a linear function is always symmetrical. Okay. Next, I do b. I plus b to it. So in this case, I plus 2 to it. Now if I add 2 to it, 0 plus 2 is 2. 3 plus 2 is 5. Right? So my graph will look something like this. Now what is this point here? This point here is 0, 5. Okay. Now when the question asks you to sketch the modulus graph, you have to give the x-intercept and the y-intercept, as well as the coordinate of the vertex. So what is the coordinate of this vertex? Is 1, 2. Alright, so 1, 2. Now let's sketch the next graph. Now let's draw 2x minus 1. So cut the x-axis at y-axis at minus 1, x-axis at half. Alright, so this is half. Let's call this 1 and this is half. Next, I do the modulus. So I reflect this negative part of it upwards. So my graph looks like this. Okay? This is 1. Now let's now do the negative 2. I multiply negative 2. 1 multiplied by negative 2 is minus 2. So I can draw this graph here because I got 2 points. 2 points is enough to define a line. I think this should be a little bit up here. Alright. Now next I need to add 3 to it. Now when it is at 0, I add 3, it will become 3. This is minus 2, I add 3 becomes 1. This is minus 2 also, I add 3 becomes minus 1. So my new graph will be like this. Alright. Now let's find the coordinates of the critical point. Now this is 0, 1. This is half, 3. Now how about the x coordinate? Now to find the x coordinate, we equate y to 0. So you have 0 is equals to minus 2 into 2x, mod of 2x minus 1 plus 3. Then you bring this across, you got 2x minus 1. You got a 2 here and a 3 here. So 2x minus 1. Now you divide this 3 over 2. You have 2x minus 1 equals to 3 over 2, or 2x minus 1 equals to minus 3 over 2. Alright, then you plus 2 and divide by 2 to it. You got x is 5 out of 4. This is minus 3/4, so it might become minus half. You divide by 2 is minus 1/4. So this point is minus 1/4, 0. And this is 5 over 4, 0. Okay. Now, what is the equation for this part of the graph? Now you find that this is a negative gradient. So your equation of this graph, this part of it will be y is equals to minus 2, 2x minus 1 plus 3. This part is y is equals to minus or 2 into 2x minus 1 plus 3. Okay? Modulus function of a quadratic equation, or rather expression. Now let's draw whatever is inside the mod first. What is inside the mod is this quadratic expression. Now let's find where it cuts the x-axis for this expression. So we do a factorization, will be x minus 3 into x plus 1 equals to 0. So it cuts the x-axis at 3 or minus 1. So here or here. Now y-axis, it cut the y-axis at minus 3. Now it has the minimum at x equals to 1. The midpoint of minus 3 of 3 and minus 1 is 1. So when you put 1 inside, you get 1 minus 2 minus 3. You get minus 4. So your graph will pass through these 3 points and curve outwards. Okay? Now let's draw the modulus of it. Now how do we draw the modulus of it? Now this negative portion will be reflected upwards. So this point will be here. 1 minus 4 will now becomes 1, 4, which is here. So this is your new graph. Okay? Now the one below the x-axis will no longer be there because it's being reflected upwards already. So let me just erase it so that we will not be confused by it. Okay, let me extend this. Now, after that, we multiply this function by 2. 0 will remains at 0. Okay, this point will remains unchanged. 0 times 2 is still 0. Now this point is at 1, 4. You times 2 will be 1, 8. This was at 3. Now you times 2 becomes 6. Okay, so instead of having to redraw the graph, I simply just change the coordinates. Next, we are supposed to add 1 to it. So this graph will move up by 1. Now, so instead of I'll redraw the graph, I can move the axis down by 1. Okay? So now the axis is here. This is the new axis. You notice that this graph did not cut, does not have any roots. Okay, this one will no longer be there. Alright, and we have to change the coordinates also. This will no longer be 6, but will be